Our subject is global warming, what we know and what we don't know. Both aspects of that title are important. First of all, you notice I use global warming, not the more anodyne and oft-used title climate change. The Earth has been around for 4.568 billion years, and its climate has changed dramatically over that extended period of time. Our subject here is the rapid global warming that's occurred over the last 50 years. What we know and what we don't know is also important because this is a lecture about science. Science knowledge is always contingent. We're always learning new things. It's important to recognize what we do know and what we don't. To do that, I will label every one of my slides with one of the following, either a fact, physics, feedback, fictions, or foreshadowing. Now, to avoid epistemological argument, I define a fact as a measurement of the material world done with the best available techniques, with an assigned uncertainty because no measurement is perfect, vetted by skeptical peer review, or preferably independently reproduced. That's a measurement of nature, and we don't argue about the measurements. Physics is a model of how we knit those measurements together in order to try to understand what's happening today and to be able to predict what's going to happen in the future. Physics is a model. It is not nature itself. It is by far the most accurate, precise, and predictive model that humankind has ever developed, but it's important to recognize that it's a model, not the real world. Feedback, it turns out, to be an incredibly important component of this discussion because it contains within it many of the uncertainties we have about predicting the future, and so we'll address that a little later. There are in this debate, in the public mind at least, many fictions, and I'll explode a few of them. And finally, there's some foreshadowing, some observations of what's been going on our planet that indeed may give us some hints about what's going to happen in the future.